Good morning, children. We are going to learn area under a curve. Suppose a curve is like this and we want to find the area between x-axis and y-axis. Say it is from A to B. I want this particular area. So to find out this, what should I do? Supposing I divide each into small segments like this. The full curve when I take, it doesn't look like a rectangle. But if I take a very small strip, it will be either little bit bigger or little bit smaller. That is almost a rectangle. What is the area of the rectangle? We say length into breadth. The length is nothing but y and the small length is nothing but a small change in x, which is nothing but dx. So what is the area of the rectangle? That is y into dx. How many such rectangles are there? There are numerous rectangles. So I want the full area, means it is integration from A to B. And we already learnt integration is nothing but summation. So from A to B, I add all these rectangles, I get the entire area. So the formula is integral A to B y dx. When you start doing the problem, sometimes my answer may be negative. Remember, in lower classes we used to say area cannot be negative, so we put positive, all that. But this year we are very much particular. If the curve is above x-axis, I put plus y because above x, y is positive. Supposing the curve is below x-axis, now the area, I write the formula A equals integral A to B minus y dx because y is negative below the x-axis. The same idea, not necessary I must take y and dx. Suppose I need with y limits, say c to d. If the values are like this, now I can write the formula x into dy and the limits are from c to d. And if it is to the left of y-axis, now the area, again it is from c to d, but x is negative here. So the formula is minus x dy. So in this exercise, we are learning area under a curve fixed by x-axis or y-axis. So when you read the problem, check whether I need to find with x-axis or with y-axis. If it is x-axis, I must know two limits for x. And if it is y-axis, I must know the two limits for y. And also draw the curve and check whether the curve is above x-axis or below x-axis. Above plus y dx, below minus y dx. To the right of y plus x dy, to the left of y minus x dy. So let us proceed with the exercise problems. Exercise 9.8, question number 1. Find the area of the region bounded by 3x minus 2y plus 6 is equal to 0, x is equal to minus 3, x is equal to 1 and x-axis. The question is about a line. The very first idea, let us draw the line and check where the required area comes, whether it is above x-axis or below x-axis. To draw the line, put x 0, find out what is y. So, if I put x is equal to 0, I get 0 minus 2y equal to minus 6 or y equals 3. So, when x is 0, y value is 3. Similarly, put y equal to 0. If I put y is 0, I get 3x equals minus 6 or x is equal to minus 6 by 3, that is minus 2. So we get x value minus 2 when y value is 0. Once I know, let me plot it. 0, 3, the point is here. Minus 2, 0, the point is here. Draw the line. Now, we go back to the limits. X is equal to minus 3, x is equal to 1. X is equal to minus 3 comes here, drop a perpendicular. X is equal to 1, drop a perpendicular. As I look at the diagram, minus 3 to minus 2, the area is below x-axis, whereas minus 2 to 1, the area is above x-axis. We know the formula. When it is below, minus y dx, and when it is above, it is plus y dx. So let us write the formula. Required area is integral. We know in general area is integral y dx between the limits a to b. But in this question, minus 3 to minus 2, it is below x-axis, so minus y dx, plus minus 2 to 1, it is above x-axis. So we will simply write y dx. What is y from the given straight line? 3x minus 2y plus 6 is 0. Minus 2y equals minus 3x minus 6, or y when you divide by minus 2. It is 3 by 2x plus 3. Let me substitute. A equals integral minus 3 to minus 2 minus y. Change the symbol. Minus 3 by 2x minus 3 dx. Plus integral minus 2 to 1. It is plus y dx. That is 3 by 2x plus 3 dx. As we integrate and substitute the limits, area equals minus 3 by 2. Let us remember the formula. X becomes x square by 2 minus 3 is a constant, becomes into x. If dx is coming, 3 will become 3x between the limits minus 3 to minus 2. Plus 3 by 2 into x becomes x square by 2 plus 3 becomes 3x between the limits minus 2 to 1. As we simplify, minus 3 by 4. X square is minus 2 the whole square. Minus 3 into minus 2. Upper limit over minus lower limit. Wherever x is coming, put minus 3. Minus 3 by 4. X square is minus 3 the whole square. Minus 3 into minus 3. Plus. Now, wherever x comes, I should put 1. So, it is 3 by 4 x square plus 3 into 1 minus. Wherever x is coming, put minus 2. So, remember, upper limit minus lower limit. It is 3 by 4 into minus 2 square plus 3 into minus 2. As we simplify further, 4 cancels, minus 3 plus 6, 3 into 9, 27 by 4 minus 9 plus 3 by 4 plus 3, 4 cancels, minus 3 plus 6. 3 and 3 cancels. We are left with 9, 3 or negative symbols. Minus 3 minus 9 minus 12. Plus 6 plus 3 plus 6, we get plus 12. We are left with 27 by 4, 3 by 4. So LCM 4, 27 plus 3. Or plus 12 minus 12 cancels. My answer is 30 by 4, which can be still simplified as 15 by 2. So required area is 15 by 2 square units, and that is the answer. So what are the steps that we did? The given line we tried to plot. For plotting, let us remember, put x0 in the equation, get y. Put y0, get what is x. The 2 points as we plot in the graph and draw the line. The limits are -3 to 1. Mark -3, draw a line. Mark 1, draw a line perpendicular. -3 to -2, it is below x-axis. -2 to 1, it is above x-axis. So -3 to -2, I will write -y dx. Whereas -2 to 1, it is +y dx. As we substitute what is y from this simplification and integrate, put upper limit minus lower limit, take LCM, we get 15 by 2 square units. Question number 2, find the area of the region bounded by 2x minus y plus 1 equals to 0, y equals -1, y equals 3 and y-axis. Now the question is about y-axis. So the formula will be integral c to dx dy. What is the equation given? 2x minus y plus 1 equal to 0. From that, let me plot the line. How to do it? Put x0. What is the equation given? 2x minus y plus 1, 0. When x is equal to 0, hide this. I have minus y equals -1 or y equals 1. So when x is 0, y value is 1. Now put y equal to 0. Now I get 2x equals to -1. Putting y 0, 2x equal to -1 or x is equal to -1 by 2, or I can say -0.5. So when y is 0, x is -0.5. Plotting the 2 points in the coordinate axis, 0, 1. 0, 1. So we have plotted it. -0.50 is here. Join the 2 points and extend the line. Now, what are the limits given in the question? Y equals to -1. Y equals to -1. You drop a perpendicular. From here, I have drawn. Y equals to 3. So now I have y equal to 3, the line. Now what portion I have? Here I have the portions. How to split it? In y-axis problems, we see to the right of y-axis it is plus x dy. To the left of y-axis it is minus x dy. So -1 to +1. It is to the left of y-axis, and 1 to 3, it is to the right of y-axis. So what is my formula? Area equals -1 to +1, it is to the left, minus x dy, plus 1 to 3, it is to the right. So I have plus x dy. When it is y-axis, the formula is c to dx dy. But if the shaded portion is to the right of y-axis plus x dy, to the left of y-axis it is minus x dy. As we substitute, a equals integral -1 to 1. What is x? From the given equation, 2x is equal to y minus 1. Or x is equal to divide by 2. Y by 2 minus 1 by 2. What is minus x? Change the symbol. Minus y by 2 plus 1 by 2 dy. Plus Integral 1 to 3. Plus 6 dy will be y by 2 minus 1 by 2 dy. Let us integrate. Minus 1 by 2, right, as it is. Y will become y square by 2 plus 1 by 2 will come as it is. Constant becomes into y. So half becomes half into y. In the previous problem we had dx. So we put x. Now I have dy. So I have to put y. Between the limits minus 1 to 1 plus y by 2. This by 2 you keep as it is. Y will become y square by 2 minus half will become half into y. Why do I put y? If it is dx, you put x. If it is dy, you have to put y because now the variable is y. So half dy will become half into y. We have completed the integration. Put the limits from 1 to 3. As we simplify, a equals minus 2 2s are 4, so 1 by 4. Y square becomes 1 square plus half into y becomes 1. Upper limit over, put minus symbol. Now wherever y comes, put minus 1. Minus 1 by 4. In the place of y, put minus 1 the whole square. Plus half into, in the place of y, put minus 1. Plus, as I put the upper limit 3, 1 by 4 into 3 square minus half into 3. Then minus lower limit. Wherever y comes, put 1. 1 by 4 into 1 square minus half into 1. Simplifying, it is 1 square is 1 minus 1 by 4 plus 1 by 2 minus into minus plus 1 by 4. Minus 1 square is 1, ignore. Minus into minus plus 1 by 2. 3 square is 9, 9 by 4 plus symbol. Minus 3 by 2. 1 square is 1, 1 into 1 by 4 minus symbol. Minus 1 by 4. Minus into minus plus 1 by 2. Check whether any terms get cancelled. Plus 1 by 4 minus 1 by 4 cancels. Taking LCM 4. It is 2 plus 2 plus 9 minus 6 minus 1 plus 2. Simplifying, we get 2. Required area is 2 square units and hence the problem. Question number 3. Area of the region bounded by the curve 2 plus x minus x square plus y equals to 0. X is equal to minus 3, x is equal to 3 and x axis. As I look at the curve equation, let me guess what type of curve it will be. We have square only for x and y is having single degree. Such type of curves we have seen in parabola. Remember, we have learnt in two-dimensional geometry 4 type of curves. How about the equation? You have x square. If I rewrite this, minus x square plus x equals minus y minus 2, or x square minus x equals y plus 2. X the whole square. Right hand side y is positive. X the whole square. Right hand side I have y to have positive coefficient is a parabola that opens up. How should I draw the diagram? To draw it in a simple way, in the given equation 2 plus x minus x square plus y equal to 0. Let me put y equal to 0 to draw it in a simple manner, because once I see one variable with square, one variable without square, I can easily guess it is a parabola, even without simplifying. X square positive, y positive, so it's a parabola opening up. Once I know what pattern it is, put y equal to 0. I get 2 plus x minus x square 0, or x square minus x minus 2 0, or factorizing x minus 2 into x plus 1 0, or I get x is 2 and minus 1. So the curve opens up cutting x-axis at 2 and minus 1. 2 and minus 1. We have drawn a rough sketch of the diagram. Now, let us plot the points minus 3 plus 3. As I plot minus 3 and plus 3, look at the portion of the curve. The portion of the curve is 3 parts. One part, as I see, it is above x-axis. Another part, as I see, it is below x-axis. The third part, as I see, it is above x-axis. So, the given area is split into 3 different parts. So, what is area formula? It is integral a to b y dx. In this problem, how will I write it? There are 3 portions. Minus 3 to minus 1. The portion is above x-axis, so I will write y dx. Plus minus 1 to plus 2. The portion is below x-axis, so minus y dx. Plus 2 to 3. The portion is above x-axis, so it is plus y dx. Now we need to find all this, getting y from the given equation. Y equal to minus 2 minus x plus x square. So I can rewrite it y equals x square minus x minus 2. Call it as number 1. I need minus y also. What is minus y? Change the symbol. Minus x square plus x plus 2. So these two, let me substitute in the integral. As I substitute, a equals integral minus 3 to minus 1 y dx. What is y? X squared minus x minus 2 dx. Plus integral minus 1 to 2 minus y dx. What is minus y? Minus x square plus x plus 2 into dx. Plus integral 2 to 3, it is plus y dx. So x square minus x minus 2 into dx. As we integrate, a very simple formula, x square becomes x cube by 3, x becomes x square by 2, constant becomes 2x between the limits minus 3 to minus 1. The same we will repeat in the second and third integral. As we apply the limits, a equals, wherever x is coming, put minus 1. Minus 1 cube is minus 1 by 3. Minus 1 square is 1 by 2. Minus 1 into minus 2 is plus 2. Upper limit over minus. Lower limit. Wherever x is coming, put minus 3. Minus 3 cube is minus 27 by 3. Minus 3 square is 9 by 2. But already there is a minus symbol. Write as it is. Minus into minus plus 2 3s are 6. Same way, do for the second and third answer. Wherever x is coming, put 2. Minus 2 cube by 3 plus 2 square by 2 plus 2 into 2. minus, wherever x is coming, put minus 1. Minus 1 cube is minus 1 into minus. So it is plus 1 by 3. Minus 1 square is 1 by 2 plus 2 into minus 1 minus 2 plus wherever x is coming, put 3. 3 cube by 3 minus 3 square by 2 minus 2 into 3. Then lower limit, 2 cube by 3 minus 2 square by 2 minus 2 into 2 minus 4. Let us simplify further. Collecting all the whole numbers together, 2, 9, minus 6, 2, 4, 2, 9, minus 6, 2, 4. We get 22. Collecting all by 3 terms together, minus 1, minus 8, minus 1, minus 8 by 3. Collecting all by 2 terms together, minus 1 plus 9, minus 1 minus 9. As we simplify, it is 22 minus 18 by 3 minus 2 by 2, or we get A equals 22 minus 6 minus 1, that is 15 square units, and hence the problem. So the simple problem, the main thing that we need to identify is when one variable with square and one without square, most likely curve is a parabola. If I bring this to the other side, x square positive, y positive, I get it is a parabola opening up. To get where it cuts x-axis, put y equal to 0 in the given equation. As I solve, I get x is 2 and minus 1. So I know it's opening up parabola passing through 2 and minus 1. Now, the limits given in the question are minus 3 and 3. Plot minus 3 and 3. As we plot it, we have 3 different areas. Minus 3 to minus 1 above x-axis plus y dx. Minus 1 to 2 below x-axis minus y dx. 2 to 3 above x-axis, so it is plus y dx. What is y? From the equation we rewrite, get what is y and minus y. Substituting and integrating. Put upper limit minus lower limit. You need to calculate very slowly and accurately to get area equals 15 square units, and that is the answer.